Thank you, David. And kind of along the same lines as the previous two speakers, and I'll probably draw some from some principles that they had just talked about here. This will be an example of a concrete foundation where some of the evidence would suggest that there should be massive corrosion, but there was in fact no corrosion. So oftentimes when we encounter situations like this where we have some data that's that suggests something that we don't necessarily understand, we oftentimes do consult with other corrosion specialists. So, and this was one such case, and it just turns out to be very interesting. So here we go. This was a steel plate tank with a steel floor, and the steel floor was bearing directly on a concrete foundation. The tank was built in the 1960s, and it was approximately 60 foot in diameter by 42 feet tall, and it was used for the store of hydrochloric acid. There was a thin layer of like a black sand between the floor and the foundation, and the owner had observed some slight leaks in the tank, and so they were engaging into a project where they were going to replace the floor to stop the leaks. And while we had that opportunity, they had requested that we come in and review the foundation. One of the challenges of this project is once they cut a hole into the wall, our timeline for doing testing, for getting results was very short. So we had to work under a very short duration of time. But at the same time, we wanted to have this take this opportunity while we had access to a normal part of the foundation that we normally wouldn't have, to get as much data as we possibly could. One of the goals as the owner was going to replace the steel plate, one of the goals that we were tasked with was to determine if the concrete foundation had been compromised because of the leaks, and to provide some recommendations for the long-term restoration of the foundation. Our task that we had proposed to the owner to do while the floor was out was the following visual observations. Typically, when we do visual observations, that includes sounding. We took 5 cores on the interior. We also performed some pull-out tests, some pH tests. We sent a few of the cores out for a chloride test, and we also did some electrical potential half cell test. This is and I know it's kind of hard. It was a very dark area in the pictures, and so, but this was a picture of the floor. The floor, the foundation was built with a slight slope in it, so the lower part of the foundation definitely had this surface type of acid attack, where the cement matrix was heavily deteriorated for approximately a ½ inch. And basically what you see there with the kind of the white popcorn sticking up, that's the aggregate sticking up. So for the most part, the aggregate was very sound. It was the concrete matrix around it that was heavily soft. I just kind of describe it as powdery. If you hit it with a hammer, it breaks away really easily, again, for this upper surface. This type of observation was, again, for about half of the area of the foundation. The other half of the area toward the upper half of the slope was, it was a little more smooth. It was still had that soft and powdery feel to it, but for the most part, it looked in much better condition. We did do some soundings with a hammer and in all areas, and the soundings did indicate that there were no delaminations. I'd also like to add that since this structure was so old, and actually this structure had been had a change of ownership, I guess roughly 5 or 10 years ago, and the new owner didn't really have the best of records on it. and the foundation drawings that we were provided were actually not the foundation that this ended up being. So we were kind of really going into this situation with a lot of known unknowns, and so to speak. We felt pretty sure, based on some of the other tank foundations in the area, that this was a pile-supported slab. And based on some of these other tests, we definitely found a very large mat of rebar a few inches below the floor surface here. So, and I'll have another. This is a little closer up view. The water here was from the core. Because of our truncated timeline, I was doing the documentation while we were taking cores and performing these other tests. It was all happening at the same time. But yeah, you can definitely see some of the surface deterioration here. I have some pictures here of the cores. This core, what I call core 1, was taken in a bad area. And from the side view of the core, you can definitely see that there was, as we confirmed from our soundings, that there were no delaminations. And then the surface, again, was very rough. The next core is a core actually taken from a good area. And even though its surface is still a little rough, in reality, when you're out there, you can definitely tell that it was a little bit smoother than the one. And so this is a core number 3 over here, was also taken in a bad area. So these were the 3 cores that we sent off to the lab for some chloride testing. Cores 4 and 5 were taken in the bad areas, and we kept these for our pH testing. As you can see from the very surface, that it was extremely rough from the deterioration of the cement matrix. We did the pull-out test in 2 locations. We tried to do one on the surface. Again, the surface was pretty rough and bad, but by the time they surface prep, they ended up probably going down a little bit from the surface to do it. We did one set of readings from a good location and one set of readings from a deteriorated location. We kind of dismissed the results from the surface on the deteriorated location. We think that maybe this was taken at a point where they had a very large aggregate nearby, and it just threw off the results. But what really caught our attention is that once you got down 1 inch and 2 inch, the deterioration was slightly less than that of the good surface here for the pull-out test. A good bonding strength for 4,000 psi concrete is typically at around 250 psi. So these results, even though one was a little bit worse than the other, are still kind of indicative that the cement and the concrete itself is in relatively good condition. So this, in a way, this validates a lot of the visual results that we saw and the core results. Another test that validated that the concrete condition was in good condition was the pH test. And this was done on cores 4 and 5 in a bad area. And basically, I did this test right after we got the cores to the office, and I did some photo documentation. And then right then, I started breaking them apart and doing some tests. And the phenolphthalein test showed that we had a magenta reading, which indicates that the pH was above 8.6, and thus the concrete really hadn't had that carbonation attack that we are accustomed to seeing a lot of times in corroded concrete areas. So these everything that we've done so far has kind of shown that, hey, that the concrete is in really good shape. However, it's the last 2 tests that really caught our attention, and kind of made us wonder if there was any potential problems that we needed to be concerned about. And the first of those tests is the chloride testing. And this kind of ties in a little bit with Ali's presentation before, where he had stated that 260 parts per million threshold is kind of a good indicator for where corrosion could start, roughly in that 20% chance, and then we have 500 parts per million, where we have a much greater chance of getting corrosion. Well, in all of our cores, in core 1 and core 3, again, in the bad areas, core 2, and in the better areas, we have seen that we have amount of chloride that grossly exceeds, these limits that, that we're accustomed to seeing. So, this kind of made us a little nervous. We did these tests at in half-inch increments. The surface 0 to 1/2 to 2.5 to 3 inches, and even in the deeper areas, we're having extremely high chloride contents, and hydrochloric acid definitely is a material that contains a lot of chloride. So the fact that in a way, the fact that we did have a lot of chlorides on the surface here was not unexpected. I think it was the high content that really caught our attention. The other test that kind of correlated to this finding was the electrical potential or half cell test, and this is a summary of the results of that. As stated, I believe David and maybe Ali had both stated this, that an indicator, normally a potential of around negative 300 millivolts would indicate a corrosion. Well, for this area, and again, we broke away two pockets, two large pockets to expose the rebar. In those pockets, the rebar was in perfect condition, and to do this test, and we got readings typically in the range of -290 to -666. So, this test also indicated that we probably should be seeing a lot of corrosion. And again, it just wasn't happening. This here is kind of a plan of the floor plan that shows a summary of what we did and where we did it. This bottom part of the plan is the lower part, and the hatch area was the area where we had that surface matrix deterioration. The upper part of it here was in a lot better shape. We kind of show here where core 1, core 3, core 4, and core 5. Cores 1 and 3, we did the chloride test. 4 and 5, we did the phenolphthalein test. Core 2, we did up here. And here was one of the areas where we chipped out to do an electrical potential test. And here was the second area. And we had a couple of areas where we did the pull-out test. I'll zoom in to this area of interest so that we can see our numbers a little bit better. So the chloride contents here are summarized in this table at this location. And then, the same thing here for this location. Again, all very, very high numbers. This was where we did our pull-out test, and it was very good. And then this was an electrical potential test where, we had, again, a very high electrical potential reading. So the unusual finding in our case is that we had high chlorides plus a high electrical potential, but yet we had a perfect mat of rebar. And, being that the foundation was as old as it is, I mean, we're talking, well over 50 years old. It was a little bit, again, going back to our task of trying to determine if there's, anything that we need to do to rehab the structure, we were kind of struggling with the idea of, hey, will these indicators, tell us if that, shortly after they put this back in service, that this foundation is going to have a lot of problems. This goes back a little bit to David Whitmore's presentation, and that typically, the conditions required for corrosion to begin, we need a loss of passivation or carbonation, we need the presence of moisture, and we need the presence of oxygen. And what we rationalized is here in the center part of this tank, that it was very likely that the tank had been sealed off from moisture and oxygen. And that would kind of explain why we were getting very good pH readings near the surface of the foundation. And obviously, being in the middle of the tank, it's not exposed to any kind of weathering or that kind of thing. Another idea, and again, this kind of goes back to being to having a relatively new owner who may not be familiar with everything that had been installed in other parts of the plant around this area. There may be other CP systems nearby for the other tanks that could be also helping our tank in a way. So those were the two explanations that we provided to the owner. We did have a couple of options for the owner if they were interested in preserving the top of their foundation. Kind of the good option was really not to do anything, since there was no beyond where we had the problems, that they didn't do anything. A better option would be to put a very dense concrete topping over the area, and then a best option would be a topping with a vinyl ester liner. Due to the time constraints, the owner basically had chosen to do nothing at this time. Even though I didn't go over it in a whole lot of detail, we did have some tests run on the exterior of the foundation. We could see anywhere from like 18 inches down here to roughly about 3 foot over here of the exterior of the foundation. They did have, several small vertical cracks all the way around. We were obviously, since we were concerned about the moisture potentially penetrating into the center of the foundation, we did end up doing, and the owner chose to do, was to seal these cracks. We used an epoxy sealant in those cracks, and then we did a resurfacing of the perimeter of the foundation above the ground. We did not excavate into the ground in a location like this. That usually incorporates, other environmental issues that sometimes we don't want to disturb. So we just went ahead above the ground and resurfaced it, so that, with the idea being that we're going to try to seal off the water from penetrating into the center of the foundation. Yeah, that pretty much summarizes our findings for this, and that concludes this discussion. I'd like to lay a disclaimer that I am not necessarily the best expert in corrosion engineering beyond attending, all these presentations. Whenever I get into situations where the basic understanding, the general fundamentals kind of don't match with the observations we're seeing, I definitely like to get other corrosion experts involved. So if hopefully if there's any questions, I can try to address them, but I may not be the best at answering these things.
Thanks, Peter. Very interesting talk. There was a question that came in from Leah, and she asked, what was the rebar type? Because she had commented about the corrosion potentials being for black steel.
I guess rebar type is in like standard reinforcing, or
I think I don't want to speak
Yeah.
for her, but I'm guessing if there was.
We didn't see any coding or anything. Again, we didn't have, unfortunately, we didn't have any drawings, but it definitely was kind of like a standard uncoded reinforcing. I know that there were some slides in the previous presentation where they were epoxy coated. It was nothing like that was observed.
Okay, great. Any other questions?
I have a question, David. Peter, great presentation. You may not consider yourself an expert, but you certainly have been paying attention. You've attended all of these committees and discussions. Most of the work you did is good. I have a question regarding your finding about other cathodic protection systems in a tank farm environment. This is common to protect the tank bottoms with some press current cathodic protection. Did you find that in the vicinity? Question number one. And question number two, was the rebar in the foundation electrically connected to the grounding grid in the area? And the reason I'm asking these questions is that it might have, it may be an explanation. I'm certainly guessing from where I sit now, but it might explain the highly negative potentials.
The answer to both questions is we don't know.
Okay.
Unfortunately, like I said, we basically went into this blind that the owner had thought they had given us the correct drawings for the foundation. We quickly realized that we had not, and then we asked the owner if they had any other drawings, and they said no. Basically, the change in ownership probably produced a lack of handover of these types of things. And with the tank being this old, even the original owner may not have had those documents anymore. So and then in terms of whether or not there was another a system nearby, the owner was not aware of anything. Again, I state that doesn't necessarily mean there wasn't one somewhere else. It's again, being the new owner, a lot of the people that we're dealing with, they weren't local to this site. They were from a home office, so the amount of information they probably knew, they just they didn't know.
Thank you, Peter. I appreciate it.